Okay, so alkylation reaction we have seen when we were doing the method of preparation also. Okay, if you have 1 degree amine and I react it with alkyl halide, I have 1 degree amine RNH2 and I react it with some alkyl halide R-X, then this R will be having delta positive because it is attached with electronegative element X. And this lone pair electron is what it is, electron rich, so it will attack on this R carbon atom and this X is going to leave. And first of all, you are going to get R bonded to nitrogen. This nitrogen has 2 hydrogens and it is further bonded to R dash. So this R dash and this R dash are the same R dashes. Okay. So what is happening to nitrogen atom? Nitrogen is getting alkylated because it is having an extra alkyl group R dash. Now, this nitrogen will also have a positive charge because it is bonded to 4. It is bonded to 4 different groups. And when you react it with some base, this base will abstract the hydrogen and you will get Rn with 1 hydrogen and R dash. Okay, so what is the use of this base? This base abstracts the hydrogen. Okay, now please start writing. This amine will can also react with R dash X, and further it will give R, N, R dash, and one more R dash. Okay, so from 1 degree, this is 2 degree, and this is 3 degree. Right, for example. PR लिख लीजिए यहाँ पे. This nitrogen atom will attack onto this carbon atom, and we'll get CH3 NH attached with 2 carbon atoms, ethyl group. 1 carbon atom and 2 carbon atom. These 2 carbon atoms are same as these 2 carbon atoms. To further react, and you will get write this, and then I will tell you how to name this type of amines where you have more than 1 alkyl group. All of you wrote this down, yes or no?
Yes, sir.
Okay. देखिए. In this, how are we going to name it? First of all, we identify the functional group. Okay. In functional group, as soon as you see a nitrogen atom, which is connected with alkyl group, any carbon atom, any alkyl chain, then this will be what? It will be amine. Functional group is what? It is amine. Now, unsaturation, it will be AN because there is no double bond or triple bond. The parent. Now, parent is that carbon atom which should have the functional group if functional group is present. But as you can see in this particular molecule, this CH3 is also connected to the nitrogen atom, that is amine. These ethyl groups are also connected, but we can choose any one of them. So we are going to choose the longest chain because all of them are same until we go to the longest chain. Because this carbon is also, methyl is also attached with nitrogen, ethyl is also attached. Okay, so we cannot decide according to the functional group. We have to decide according to the longest chain. So the longest chain is ethyl with 2 carbon atoms. So the parent will be eth. Now substituent. After the identification of functional group, that is nitrogen and amine, and the unsaturation and parent, whatever remains is what? It is a substituent. So we have 2 substituent here. This is methyl CH3 and this is ethyl, that is C2H5. Now we have methyl and ethyl. These are the substituent. But how do we number the substituent? Since these substituents are not attached directly to the carbon chain, it is not attached to the main chain. Hence, we are going to number it according to nitrogen because it is attached with nitrogen. So you'll say it is N-methyl. That means it is attached on the nitrogen atom. And this is N-ethyl. Okay, so this is what? Now, when we are going to name it down, so we'll write N-ethyl N-methyl ethane amine. Okay, so the name will be N-ethyl N-methyl ethane amine. Okay, please write this down. And this one, it will be having N-methyl because that is the only substituent. Then you will have ethane amine. Right, next 4th reaction. नवाल एंड हनीफा, आपको नेमिंग समझ में आया? यस नवाल, यस हनीफा?
Yes, sir.
ठीक है. 4th reaction, कार्बाइल अमीन reaction. In carbyl amine reaction, you have RNH2. It reacts with chloroform in basic medium with some heat. You will get RNC. This is known as carbyl amine or isocyanate. इसका क्या नाम होता है? एक तो isocyanate आप लोगों को पता होगा. Also known as carbyl amine. Plus KCl and H2O. Now this carbyl amine, it has very bad smell. It has a very foul smell, and that is why it is used for the detection of 1 degree amine. So it can give reaction only with 1 degree amines. So please write aliphatic and aromatic 1 degree amine. 1 degree amine reacts with chloroform. Reacts with chloroform and KOH at elevated temperature to form isocyanide. Right, next. Isocyanide has a very foul smell. Therefore, this reaction is used for detection of 1 degree amines. Right, next. Fifth reaction. Reaction with nitrous acid. Reaction with nitrous acid मिलके. First of all, what is nitrous acid? It is ONO. HONO. ONO. Please write ONO is prepared in C2 by the reaction of NaNO2 plus HCl at low temperature. Now, different types of amines, for example, primary amine, secondary amine, tertiary amine, and aromatic amines. All of these things, they show different reaction with, they show different type of reaction. They give different product when we react it with HONO. So if I look at primary amine, you have RNH2, and in RNH2 we add NaNO2 plus HCl. Okay, NaNO2 plus HCl, and we get R bonded to nitrogen, which is triply bonded to another nitrogen with a positive charge on this nitrogen atom, and Cl negative. The Cl negative is coming from HCl. Okay, this is what? This is a alkyl disonium chloride. So it is a disonium salt, and it is what? Alkyl disonium chloride. And this is very reactive. It even reacts with moisture, that is H2O, and we get 1 degree alcohol. Plus nitrogen gas and HCl. When the same reaction happens with aniline, that is aromatic amine, in 0 to 5 degrees Celsius, we get benzene disonium chloride. Now benzene diazonium chloride, it is stable because of resonance, है ना? इसके बारे में तो पढ़ेंगे हम लोग. It is a complete topic, diazonium salt, right? Benzene, diazonium chloride. Now 2 degree and 3 degree आपके syllabus में नहीं है, तो इस वजह से you write it like this. You have 2 alkyl groups bonded to nitrogen with 1 hydrogen. It reacts with ONO to give water, and it forms R2N as it is. Now this N is doubly bonded with the nitrogen atom, and this is doubly bonded to, wait a second, this nitrogen is singly bonded to the nitrogen, which is doubly bonded to oxygen. Okay, this is known as nitrosoamine. And this water molecule leaves like this. Okay, so you will get plus H2O. Now when we have tertiary amine, 3 alkyl groups plus ONO, you get here first of all a salt in which we have R3 and H. This nitrogen has positive, and you have NO2 negative. Okay, but it is not very stable. If you just warm it, we are going to get nitrosamine once again. R2 singly bond, R2 with nitrogen, singly bonded with nitrogen, doubly bonded with oxygen. Plus, well, plus we get ROH, alcohol. I write this down. Done, everyone?
Yes, sir.
All right, the sixth reaction, this is important. The sixth reaction is also a test. This can be used for the distinguishing between 1 degree, 2 degree, and 3 degree amines. Right, the sixth one, a reaction with aryl sulfonyl chloride. What is aryl sulfonyl chloride? It has a structure in which benzene ring is attached with sulfur. And chlorine. This is also known as Hinsberg's reagent. Now, first of all, what happens? This is used for distinction of 1 degree, 2 degree, and 3 degree amines. 1 degree amine plus Hinsberg's reagent. You will get a product, and this product will be soluble in alkali. If you take 2 degree amine plus Hinsberg's reagent, you will get a product which will be not soluble in alkali. Then you have 3 degree amine plus Hinsberg's reagent. This will give you no product. This will give you no product. Now look at the reaction. You have benzene ring, S double bond O, chlorine plus hydrogen bonded to nitrogen. So has one more hydrogen and it is bonded with R group. This is primary amine. In primary amine, this HCl leaves. Okay. The reaction is very similar to that of acylation. वहाँ पे कार्बन एंड नाइट्रोजन का बॉन्ड बनता है, यहाँ पे सल्फर एंड नाइट्रोजन का बॉन्ड बनता है. Basically, this nitrogen atom, it attacks on the sulfur and this chlorine leaves. Okay. So what we are going to get? Please see. We'll get the same benzene ring with sulfur double bond O, and rather than bond with Cl, it has a bond with nitrogen. This nitrogen is further attached to hydrogen, an alkyl group and one hydrogen here. Now this hydrogen, this is very acidic hydrogen. Why is it acidic hydrogen? Because this hydrogen is acidic because if I am going to remove this hydrogen, let us suppose we remove this hydrogen. So you will get a negative charge here. This negative charge will be in resonance with the sulfur, double bond O, and also the benzene ring. So what we can say, our conjugate base is going to be stable. When the conjugate base is stable, we are going to easily get this hydrogen as acidic hydrogen. If when this hydrogen leaves, the nitrogen will say, okay, fine, you can leave because the negative charge that I am getting is in resonance and I am stabilized. So this hydrogen is very acidic. And because it is acidic, therefore soluble in alkali. It is soluble in alkali. Now let us look what happens with 2 degree amine. We have hydrogen, nitrogen, R group, and one more R group. The benzene ring, sulfur double bond O, nitrogen with one R and another R. ये तो आपका HCl ले गया, right? We had only one hydrogen that is taken by, that is leaving as HCl. See here you'll say no acidic hydrogen. Therefore not soluble. In alkali. Now since 3 degree amine, it will not have any hydrogen attached to nitrogen atom. That is why it does not react with Hinsberg reagent. So like 3 degree amine does not react with Hinsberg reagent because they do not have any hydrogen or nitrogen. Done guys? लिख लिया आप लोगों ने? अनीफा and नवाल?
Yes.
Now, right next, the last one. 6 reaction हो गए. Electrophilic aromatic substitution. Now, electrophilic aromatic substitution में, first of all, NH2 group is what it is, electron donating group. How it is electron donating group? Please see. So electrophilic aromatic substitution of aniline. ठीक है? यहाँ देखो. Now this nitrogen atom, it has lone pair electron. This lone pair electron moves here, it breaks the pi bond, and the pi bond breaks to give the negative charge. So the first resonating structure that you will see is something like this. Double bond nitrogen with 2 hydrogens and a positive charge. This bond as it is, this bond as it is, and there is a negative charge here. Okay. Similarly, this bond will move here. You will get a negative charge on the para position and again on the ortho position. ठीक है, तो आपको negative charge यहाँ पे मिलेगा, एक बार यहाँ पे मिलेगा और एक बार यहाँ पे मिलेगा. This is very similar to what we have done in phenoxide or the phenol atom. Okay. OH group is also what? Electron donating group. Now please write. This will give you a resonating hybrid, resonance hybrid structure, which looks like this. Delta negative, and delta negative. NH2 group is highly activating. And gives ortho para products. Now, right, first of all, bromination. NH2, we have aniline. Aniline will react with aqueous bromine, bromine water, and we get tri-substituted product. Br2 in the ortho, Br2 in the para, and Br again in the ortho position. ठीक है? हम लोगों को क्या मिल रहा है? We are getting tri-substituted product. Why? Because it is highly activating, and all the ortho and para groups, they get bromine at once only. Like next. NH2 is highly activating. And gives tri-substituted product. To control this, acylation with acetic anhydride is done. Followed by desired electrophilic aromatic substitution. First of all, what we do? Acylation. जो last reaction था ना, last class का, that reaction. You have here NH2 and you react this with acetic anhydride. Acetic anhydride is CS3, C double bond O, oxygen with C double bond O, CS3. Okay. So what we are going to get? We are going to get benzene ring as it is. Nitrogen with one hydrogen, oxygen. Sorry, nitrogen will attach to carbonyl carbon, double bond O, and you will have CS3. Now this nitrogen lone pair electron, it can be resonance in with this oxygen atom also, and it can be resonance with this benzene ring also. So this lone pair electron, it is what it is? Diverted towards carbonyl carbon. It is not only activating the benzene ring, it is not only giving the electron towards the benzene ring, it is also moving towards the carbonyl carbon. So it is diverted and its activating power decreases because it has to do resonance with carbonyl carbon also. Okay, so both of these directions are possible. And further, what do we do? Since the activating power is decreased, we now react it with bromine water. And we get this benzene ring as it is, nitrogen and H, C double bond O, CS3, and one bromine in the para position. This ortho position is not attached with Br. The Br cannot attack on the ortho position because it is highly sterically hindered. And because this acyl group, it will not give space for the bromine atom to attack here. That is why bromine is not attached on the ortho position. यहाँ पे क्यों नहीं attach हो रहा ortho में? Because it is sterically hindered. Now, to get the NH2 back, we react this with H plus or OH negative in water. This is NH2 and we get the PR as it is. Okay, so this is P bromo aniline. और ये क्या है आपका? This is aniline. जब भी आपके पास conversion आए, aniline to P bromo aniline, then you will surely and first of all you will do acylation, then only you will get P bromo. Otherwise आपको क्या मिल जाएगा? Tri substitute मिल जाएगा. Okay, so remember this. Right here. After acylation, the lone pair of nitrogen is also in resonance with carbonyl group. Hence, the activating power decreases. And we get P bromo aniline. You will also show the resonance here like this. Phenyl ring attached with nitrogen atom with one hydrogen lone pair and carbonyl carbon which is attached with CS3. So this nitrogen will move here. This lone pi electron will move to the oxygen, and you'll get another resonating structure in which you have pH bonded to nitrogen, doubly bonded to carbon atom, one bond with hydrogen and positive charge. This carbon has a single bond with oxygen, negative, and CS3. Okay, so this is the resonance. Also, right, due to steric hindrance, it's due to steric hindrance after bromination. Ortho product is not formed. ortho product is not formed. ये लिखिएगा नाइट्रेशन. You have concentrated HNO3 and we use concentrated H2SO4. Now, nitration is also important. इसमें क्या होता है आपके पास? You get 3 products. एक तो आपके पास para substituted NO2 plus you get meta substituted NO2. And you also get ortho substituted NO2. The highest percentage is with 51% of para. Now significant, the second highest and very significant amount of meta product is formed, that is 47%, and 2% of ortho product. Now why does meta product is formed? Meta product is formed because concentrated HNO3, please listen very carefully, concentrated HNO3 and concentrated H2SO4, they both are going to give plenty and plenty of H plus ion. So around aniline, you will have too many H plus ion just surrounding aniline. Now aniline is not very sharif. It has lone pair electron. So lone pair electron will attack on the H plus ion. Now as soon as the lone pair electron attacks, nitrogen gets 3 hydrogens. That means it has now 4 bonds and a positive charge. That positive charge makes this ring, that positive charge, it becomes deactivating and it pulls the electron from the benzene ring, making it what? Making it meta-directing. So please write, in presence of concentrated acid, in presence of concentrated acid, NH2 of aniline gets protonated. Protonated to NH3 with nitrogen having a positive charge. Making it electron withdrawing group and meta-directing. And meta-directing. Therefore, we get significant amount of meta product. After this, you write sulfonation. In sulfonation, you have aniline. You react this with concentrated H2SO4. It forms a salt in which you have NH3 positive with HSO4 negative. And when you warm it, we'll get NH2 and SO3H. This is known as sulfonilic acid. Okay. Now this sulfonilic acid is in equilibrium with So this hydrogen here, it is acidic, and this nitrogen has a lone pair electron. So we get a Zwitter ion type of thing with NH3 positive here and SO3 negative. Okay. ये चीज important है that this is a Zwitter ion. Zwitter ion is what? It is having positive and negative charge both on the same molecule. Positive and negative charge are on the same molecule. That is why it is known as Zwitter ion. जैसा आपके पास amines के केस में होता है. अमीन बोल रहे हैं. Amino acid के केस में होता है. Now write a note. And please write here, aniline does not show Friedel-Crafts reaction. Friedel-Crafts reaction कौन से होते हैं? Friedel-Crafts alkylation भी and Friedel-Crafts acylation. Why? Aniline does not show Friedel-Crafts reaction due to the formation of salt with AlCl3. है ना? तो AlCl3 कहाँ से आया? AlCl3 is the Lewis acid that is used as catalyst. Salt with AlCl3, the Lewis acid used as catalyst. Due to this, nitrogen of aniline gets positive charge. Positive charge and acts as strong deactivating group. And does not show Friedel-Crafts alkylation and acylation. Shall we write this down? Is everyone done? Nawal and Hanifa?
Yes, sir.
That's it for today.